7.1 Rational Expressions. A rational expression is a fraction with variables. Whenever you have a variable in the denominator, there is a chance that the expression will be undefined. You cannot divide by 0. When you have variables in the denominator, you have to identify what x cannot be. Anything divided by 0 is undefined. Part 1. Find all numbers for which each expression is undefined. Example 1. 11 divided by 3x. To find what x cannot be, set the bottom equal to 0 and solve for x. 3x equals 0. Divide by 3 on both sides. X equals 0 is the value that x cannot be, because 0 divided by 3 is 0. Example 2. X over x minus 6. Set the denominator equal to 0 and solve for x. X minus 6 equals 0. Add 6 on both sides. 0 plus 6 equals 6. X equals 6 is the value that x cannot be. Example 3. 17 divided by 6x minus 30. Set the denominator equal to 0 and solve for x. 6x minus 30 equals 0. Add 30 on both sides. 0 plus 30 would give you 30. 6x equals 30. Divide by 6 on both sides. 30 divided by 6 equals 5. X equals 5 is the value that x cannot be. Example 4. X plus 5 divided by x plus 7, x minus 9. Set the denominator equal to 0 and solve for x. X plus 6 times x minus 9 equals 0. When two things multiply to equal 0, one must be 0. Solve each one. For the one on the left, subtract 7 on both sides. 0 minus 7 is negative 7. On the other one, add 9 to both sides. 0 plus 9 is 9. X equals negative 7 or x equals 9 are the values x cannot be. Part 2. Simplifying. Simplify each expression. Example 5. 9x squared divided by 6x. Reduce 9x over 6 by dividing each by 3 since 3 goes into both. Simplify the variables using exponent rules. Subtract exponents when dividing. Or write out x squared as x times x and cancel 1x. So 9x squared is 9 times x over 6x. 3 goes into 9 3 times. 3 goes into 6 2 times. And cancel x. 3x over 2. Example 6. Simplify. Find out what can go into all 3. Divide 3 into everything. 3x divided by 3 is x. 9 divided by 3 is 3. 6x divided by 3 is 2x. X minus 3 divided by 2x is the answer. Example 7, simplify. X plus 4 divided by x squared minus 16. Anytime you have x squared, factor and see if anything crosses out, the bottom factors. So the x squared minus 16 becomes x plus 4 times x minus 4. Now we're having x plus 4 on top, and we're going to divide it with x plus 4 on bottom. And anything divided by itself equals 1, so that's why we have 1 on top, and then x minus 4 is left on bottom. We factored the x squared minus 16 to equal x plus 4, x minus 4. Example 8, simplify. 6y plus 18 over 11y plus 33. Take the GC of 6 out of the top, take the GC of 11 out of the bottom, and then you're going to cancel the y plus 3. So 6 goes into 6 and 18. 11 goes into 11y and 33. So put in the parentheses what needs to multiply to equal each of them when you distribute. And then the y plus 3's cancel, so you have 6 over 11. Example 9, simplify. X plus 2 divided by x squared minus x minus 6. Factor the bottom. X squared minus x minus 6 factors into x plus 2 times x minus 3. and then cancel the x plus 2's. The x plus 2's divide to equal 1, so we have 1 divided by x minus 3. Example 10, simplify. X squared minus 12x plus 36. X squared minus 12x plus 36 factors into x minus 6 times x minus 6. 4x minus 24. These have a 4 in common, so take out the common factor of 4. Divide out the x minus 6 on top with the bottom, and you're left with x minus 6 divided by 4. Example 11, simplify. Y squared plus 5y plus 4 divided by y squared minus 4y minus 5. Factor the top and factor the bottom. Cancel out the y plus 1. So the top becomes y plus 4 times y plus 1. The bottom is y minus 5, y plus 1. Divide out the y plus 1's. We have y plus 4 divided by y minus 5. That's the end.